Hello, welcome back. So in this video today, we're going to be discussing kind of the extension from the WUMPS activity that you've already done. And you'll kind of start to notice the connections between the WUMPS and what we're doing. So this unit is defining and exploring different types of transformations. So first off, what we're going to begin with is translations and reflections. Okay, translations simply just means to move an object from one place to another. The size doesn't change, the shape doesn't change, it just moves. Okay, it translates to a different area. Just like if we were translating from English to Spanish or English to Korean or whatnot, what we're saying doesn't change. The only thing that changes is the language. Okay, but our meaning is still the same. And same way with translations. Okay, so a translation is usually represented using something called a vector. Okay, and a vector in component form is going to look like this, A and B. Okay, and A is going to represent our horizontal change. So how we're going to get from one point to the next, what change we're going to go horizontally. And then B is going to represent our vertical change. Okay? So really, what this means is you're starting at a point, and in this case, anything on this first object is called your pre-image. So ABC is my pre-image. And we're going to see how do we go from B to B prime, which is your image. So B to B prime, let's see. We're going to go, what is our horizontal change? So our horizontal change is 1, 2, 3 units to the right. So that's positive. So positive 3. And then what is our vertical change? So are we going up or down, and how many units? Well, we're going up, so it's positive, and we're going up 1, 2, 3, 4, 5 units. So our vector for this translation is going to be 3, 5, and it looks just like this. So let's put that into some examples. So for an example, the vector -5, 3 in words means to shift the image. So are we going to shift left or right? Well, is A positive or negative? And it's negative. So we're going to shift to the left 5 units. And now we're going to look at 3. Now, is that positive or negative? Positive. So it's going to go upward 3 units. Okay, for our vector -5, 3. Now let's consider the vector -3, 2 in words, meaning that we're going to shift the image. Well, our vertical or our horizontal change is negative, so it's going to be going left 3 units, and then our vertical change is positive, so it's going up 2 units. Okay, and that's just simply component form. So that's component form of a vector. Okay, so let's move on a little bit. So what would be the vector for an image that is translated right 16 units and down 4 units? Well, again, we have A, B, where A is our horizontal and B is our vertical. Okay? Well, A is going to the right, so that's going to be positive. So 16, and then down 4 units. Down means it's going negative, and it's going to be 4 units down. So that's what our vector is going to look like, going right 16 units and down 4 units. So let's try to put this into a picture, so like a coordinate image. So we're starting with A, B, C, D as our pre-image. Now the pre-image is the image that you have before a transformation is used. So in this case, before a translation is used, that's our pre-image. So A, B, C, D is our pre-image. We're going to draw the image on the graph to the left. Well, actually, it's on top. When A, B, C, D is translated along the vector -5, 4. Okay, so this means that we're going to go left, because it's -5 units, and we're going to go up because it's +4 units. So you're going to start at any of these points. I'm just going to start with A based off of going in that order. And I'm going to go left 5 units and up 4 units to get A prime. So left 5 units, 1, 2, 3, 4, 5. So we go left 5 units and up 4 units. 1, 2, 3, 4. And those are arrows. I know you can't really tell. So this right here is my new A point after it's been translated. And we're going to call that A prime. Just remember A, if it doesn't have a prime or a comma after it, that means that it's the pre-image. Okay? And A prime, that's going to mean that it's the image. That's my new image. Okay? And do this for every point. So now B, I'm going to do the same. I'm going to go left 5 units and up 4 units. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is going to be B prime. Let's look at C. Left 5 units, up 4 units. C prime. And then D prime. Left 5 units. Up 4 units. Going to be D prime. Okay? So now you have your new image. Okay? So these are the points for your image. So now you've done some translations, and you should be able to go to the practice for translations and complete it. So now we're going to move on to reflections. So reflections, it's exactly what it says if you're using this in real life. If you're looking in the mirror, again, a reflection, when you look in the mirror, the image does not change. Your size doesn't change unless it's a mirror that's not very good mirror. Your size is not going to change. Your shape is not going to change. Your height doesn't change, okay? So it stays the same shape and size. It's just reflected. Now there are 3 lines that a pre-image, and let's remember a pre-image is before a transformation. Your pre-image is going to be reflected over a line. And there are 3 lines that you can actually reflect over. You can reflect over, if you look at this first picture, it's reflected over this line here. And that's the x-axis. So you can reflect over the x-axis. Okay? This second picture we have, it is oh, and I got a little mark there. You can reflect it over the y-axis. And there's one more line that you'll notice that you can reflect over, and it's the line y equals x. And it's exactly like it says, y equals x. So on this line, 1, 1 is a point, 2, 2 is a point, 3, 3 is a point, where y is going to always equal x. 4, 4, -1, -1, -2, -2. All of those points are on this line, y equals x. Okay? Now with that, there's coordinate rules. So I can show you an image, and then I can ask you to reflect it over this axis, and then you'll be able to tell what the coordinate rule is. So for the instance, y, or over the x-axis, so we're looking at this first picture here. You notice that it starts off as -7, 2. So that's our coordinate. Then it flips over that x-axis and becomes -7, so it didn't change. Our x did not change. So it's still x, but our y changed. Now our y is negative. So our coordinate rule for reflecting over the x-axis is x negative y. So that's our rule for reflecting over the x-axis. Now, if we're reflecting over the y-axis, let's consider. At first, we have -7, 8. And then it flips over that y-axis, and our negative becomes a positive. How do you make a negative a positive? Well, in order to make a negative a positive, it's going to have to be multiplied to a negative. So it's going to be -x, and then our y stays the same. It doesn't change. So our coordinate rule for reflecting over the y-axis is -x, y. And lastly, our coordinate rule for reflecting over the line y equals x. Well, let's look at this point, G. It reflects over the line y equals x, but the first point is -5, 4. Well, if you notice, it actually entirely flips. So the x becomes y, and the y becomes x, but negative. So our coordinate rule for reflecting over the line y equals x is actually -y, -x. Okay, so these are your rules for reflections. So let's try some examples. So if we're reflecting over the x-axis, okay, and this is our pre-image points. Let's go back to our rule. So reflecting over the x-axis, our coordinate rule is x negative y. Okay, so my x doesn't change and my y becomes negative. So if -4, 5 is my pre-image, my image point is going to be x. Nothing changes there. But my y is going to become negative. Well, negative times -5 is going to be +5. So it just changes sign. Well, same thing here. X stays the same, -2, but my negative now becomes positive. It just changes sign. Okay, 2, -2. X stays the same, y changes. X stays the same, y changes. Okay, so now what I want you to do is I want you to plot those points on this graph. And I also want you to go on. You'll need to pause here so that you can now do your own example. Now, remember that this one is actually reflected over the line y equals x. So our rule, you may need to go back in this video to find our rule and apply it here. Okay, but this is all that I have for you today. After you have completed these examples in here, you may move on to the practice. And if you need any help or assistance with this, please email me, let me know, and we can set up a Zoom. I will see you guys later.